Welcome to the second stop on our field tour. This is a demonstration titled Driving Response to Nitrogen Fertilizer Rate and Dryland Solid Seeded Production with funding provided by the ADOPT program. So dry beans are a relatively high value human food crop that have the potential to add diversity to regions that would normally grow soybeans, lentils, or field peas as their sole pulse crop options. Dry beans are also unique in that they are not susceptible to root rot, so they are a great option in soils that are plagued by Aphanomyces root rot. So in 2019, multiple AgriArm sites ran a trial evaluating inoculating dry beans versus fertilizing with nitrogen, and it was found that fertilizing with nitrogen was superior to inoculating in dry beans. So from that, we've developed this demonstration. So the first year of this demonstration was completed in 2020 at Indian Head, Redvers, Melfort, and Yorkton. So this is the second year of this demonstration. We're looking at different rates of nitrogen from a control of 0 and then 45, 75, 105, 135, and 165 kilograms per hectare of soil and applied nitrogen.
At 3 of 4 sites last year, our nitrogen rate had no effect on plant emergence, although at Melfort our plant densities were lower than we would have liked at about 24 to 30 plants per meter squared. This was likely due to our heavier soil and our cooler spring temperatures in 2020. As you can see in the photo in the bottom, in 2021 our plants have been growing much better due to our much warmer temperatures in the spring and summer of 2021. At Melfort, we also saw no effect on maturity with increasing nitrogen rate. However, most of our plots were killed by an early fall frost before they were able to completely mature. In contrast, at Indian Head, maturity was delayed by up to 5 days at 165 kilograms per hectare of N as compared to the control. For height, Melfort and Indian Head both demonstrated linear increases in height with increasing nitrogen rate. However, the response at Indian Head was not significant. At Melfort, we saw moderate height increases up to 135 kilograms per hectare of N. However, this was not the case at all sites. At Yorkton, there was more of a quadratic response where height was maximized at 105 kilograms per hectare of N. Moving on to yields. Yields tended to increase linearly for most sites as nitrogen rate increased, with yields maximized at 165 kilograms per hectare of nitrogen, although not all treatments were always significantly different from one another. The only site where this did not occur was Indian Head, where yields peaked at 105 kilograms per hectare of nitrogen. Lastly, seed weights at Melfort were significantly affected by increasing nitrogen rate, where the greatest gains in seed weight were found at the highest nitrogen rates of 135 and 165 kilograms per hectare of N. Slightly different trends were observed at the other 3 sites. However, all sites demonstrated the greatest seed weights at either 165 kilograms per hectare of N or at Redvers, where seed weights were maximized at 135 kilograms per hectare.
In 2021, our treatments are the same as in 2020, except our highest nitrogen rate has been reduced to 155 kilograms per hectare. This year in 2021, we also have much better plant stands at Melfort with averages of 30 to 36 plants per meter squared, which better meets our target of 40 seeds per meter squared for a seeding rate. We're seeing much less visual differences between the nitrogen rates this year. However, the plants are doing much better in our warmer climate that we're having this year. However, we could use a little bit more moisture to help the treatments with the higher nitrogen rates utilize some of that extra nitrogen. There will be a final report available on this trial this winter. We'll be evaluating plant stands, disease, height differences, maturity, yield, and then also the 1,000 kernel weights. And there will also be an economic analysis included as well. So you can catch that at our website at neag.ca and also at